Hello everybody, this is part 3 of a series of videos on this plug socket 4-way extension 10 amp with thermal overload cutout and USB 2.4 amp medium charging power supply. Now we've had a couple of these. This one's a replacement, this is a brand new replacement, but we've had a couple where this has just made a funny smell or no smell at all, and this one day you come along within the first year and there's no power coming out of here at all. Completely dead. So part 1 and part 2 of this video series deals with the evaluation of the power supply in here and the diagnosis, a fairly laborious explanation of the circuit, up close and personal with it, just for people that want to learn about power supplies and also people that want to get to sleep. So you might find it extremely boring unless you have a basic interest in how these things work. Then part 2 deals with the detailed diagnosis with a scope and voltmeters and there's discussion about what might be wrong with a conclusion at the end. And this is part 3, as I said, where we're going to talk about this thing here. So the culprit is this little board here, which you can see in the other one, but just a quick, really basic overview of what it is just that you can see it's got very few components, no fuse to speak of. The varistor is not populated to save a few pence. That's the thing that protects the electronics up this end from any transients or high voltages that might come down the mains during a power cut or a lightning strike or some sort of electrical fault happening in the system. You can get high voltages come along and it will immediately destroy these two devices. So I'm not going to go into the detail, but it is a very, very basic device. If you look at an IKEA supply, which I bought for £2.50, this is a 2 amp IKEA supply and it's many more components. It's got a proper fuse, it's got a proper varistor, it's got more capacitors, it's got glass white capacitors, it's got nice quality DC smoothing. And more importantly, look at the difference in size. This is supposed to be a 2.4 amp. This one's a 2 amp, and you can see the scale of differences there. So I would expect something to be a bit different because this is bloody unreliable, basically. Watch the other video if you want more info. So we're just going to have a look and see what's in the new one. So I've already taken the screws out, so I have had a sneaky peek in there. But look. Pop the lid off, and you can see it has been redesigned. So this is a brand new one in April 2025. This one's about a year old, and you can compare the differences. Look, completely different. It's got the components on the different side, but you can see immediately that they put a much bigger transformer. That's probably 3 times the volume of this transformer at least. You can see that they put a varistor in, which I determined last time was a missing in the original low cost. It's also got a fuse instead of a fusible resistor, okay, with a double insulation on that as well, so just better. So yeah, altogether a much beefier design on the top side. See the difference in size of this to that component there, which is the main thing that I believe burns out on these, is the transformer. And if you turn it over on the underside, it's got a similar set of chips. Okay, similar function but not the same chips. It's got different ones on there. Maybe this was made by a different company because the board layout is slightly different. But what's more worrying is this gap between AC 0 volts and the electronics has actually got smaller. Look how small that gap is. This is no way in any planet, any shape or form CE approved. If they ever did the constructor's file, because it's self-certified, everyone knows they're going to be trustworthy in China. I would think the importer of this should be pretty careful. Okay, now if you look at the IKEA board again, you can see they've got a milled slot between the high voltage and low voltage side, and the rule is you shouldn't, if you apply 2 kilovolts to the input pins on here, i.e. a main spike or voltage test. Nothing of any substance or consequence should leak across or jump across, and this is what this is for, to stop this happening in a condensing sort of fairly damp environment or a high voltage. So yeah, new one is worse in that respect, the flashover, but it's a different design and it's got a beefier transformer, and they bought the low voltage windings out on a leg, and this seems to be quite a trend at the moment on power supplies. Is that I think the IKEA one has got the similar situation there. Look, where the low voltage winding comes out of the core and comes well away from the actual high voltage side to give that spread, and you can see what that spread is supposed to be. On the IKEA one you've got the slot. So yeah, all in all, would I trust it? Chance of getting a shock? Don't know. If anything breaks down inside this device, you can get mains on these. If you get damp on the board, it will sizzle and pop. The only, well, what can I say, not CE approved, definitely not. It wouldn't stand up to any normal type of professional scrutiny, I'm afraid. So a poor thing, but it's probably more reliable than the old one. I noticed the price of these things has dropped, so their reputation must be suffering, I think. Nicely made though. It's just a shame that they've skimped on the power supply, because the rest of the plug board, it's quite nice, quite nice. So there it is anyway. So yeah, if you've got time, just subscribe down there to the titty button on the right, and thanks for watching. But yeah, if you've got one, send it back and get the latest one.